Um, okay, so welcome everybody to another edition of Current, and um, I'm delighted for this session to be joined by two graduates of UCD, one from 2015 and one from 2020. So from 2020, I'm joined by Aisling Mulligan, who, since she graduated, has been working on various projects. She's currently working from home for Grafton Architects, with Grafton Architects, and enjoying that, it seems, by all accounts. But her thesis, which was to do with aspects of the construction industry and or construction processes, let's say, and the circular economy, was recognised by the RIBA in their awards, annual awards in 2020, and won the prize for sustainable design for a part two project, which is great. And so Aisling, I think, is going to talk mostly about that today, maybe about how that's connecting to other work that she's doing. And then Rachel Holohan, who graduated in 2015, so just before Aisling started, or just as Aisling started in the school. Rachel is now in London, yeah, yep, working for Orms, and was last year given this award by the AJ, the Architects Journal, as Sustainability Champion for the work she's been doing there as their lead on sustainability. She's going to talk to us a bit about her work with the practice, and particularly about a project she worked on to do with material passports. So the way we're going to do it is, I think Rachel will go first, if that's okay, and then we'll go to Aisling, and then we'll have chance at the end. If people have questions as Aisling and Rachel are talking, if you just drop them into the chat, and they can either pick them up, or I'll harvest them if you like, and we can use them in the conversation at the end, and we'll go from there. But so listen, thank you both very much for taking your lunchtime to talk to us in our lunchtime. And Rachel, I'll hand over to you. Start.
Thank you, Hugh. Well, my pleasure. Thank you for the invitation to come and share our work. So I am just going to share my screen now, and then hopefully that has gone full size.
Yeah.
Okay, so I'm going to give a brief introduction of myself and the practice that I'm working in now, and then I'll move on to share a little bit more about that research piece. It will be quite quick and it's quite technical, so I'll share a link at the end so you can go back and read through that brochure and the research in a little bit more depth, and I'll leave my email address if anyone wants to get in touch. So the practice I'm working for is called Orms. We are based in London, and this is one of our recently completed projects, which took a 1960s brutalist building and we put a new rooftop extension on it, and is now currently operating as the Standard Hotel in London, which is quite an incredible hotel. So who are we? We have been around for about, well, over 35 years. We are about 70 people, which is medium for a London practice, and we're all based in London. Our work, it stretches across a number of sectors. We do some new buildings, but we're probably best known for our reuse and transformation projects, and the practice has a long-standing history and experience with this work. A lot of our work is in the commercial sector in London. So a lot of office spaces, but also looking at the interiors of these spaces and how people work and trying to make better places and healthier places. But we also work in hospitality and in education. So an introduction about myself. My name is Rachel Holohan. I graduated from the the master's program at UCD in 2015, and I've been at Orms now for almost 4 years. So these are some of the projects that I have worked on during my time. And my journey has been quite a good one, I think. So after my undergrad, I came to London and worked for a year at Weston Williamson and Partners, and they work a lot in the transport sector. And I was working on the Paddington Crossrail station, which is the 3 images across the top of the screen, which was a pretty incredible infrastructure project. And after my master's, I worked with ABK on this beautiful little project out in Ballymun, amongst others, but this one really made a lasting impression on me and looked at really how we can use buildings as an exemplar for sustainability. And with that experience, I moved to New York for a year there working with BKSK Architects. So I was primarily working on a luxury residential scheme, which the images are along the bottom, but actually it was trying to pursue passive house certification, which at the time was incredibly challenging with the luxury resi marketplace. So why am I here today? Well, as a practice, our sustainability manifesto is that we believe good design is inherently sustainable and should influence every decision in the design process at every level and scale, because successful sustainability is a sum of all parts. What that really means in practice is we are questioning it at every stage of the process. We haven't always been this rigorous. In 2019, we probably were about the same as everybody else, doing our best, but not doing anything particularly innovative. And a lot of this changed, our thinking started to change in the early parts of 2019, particularly when Architects Declare came out. And we started thinking long and hard about the work we've been doing, and we felt like we've been doing the right thing, but we're primarily relying on our instinct, reuse as much as we can, wherever we can. And we wanted to start putting data to back up that. So we started looking at carrying out whole life carbon assessments to understand the carbon impacts of our buildings in-house, and the work has really accelerated from there. And actually, from our research side, 2020 was an incredibly positive year because work slowed down. Instead of using the furlough scheme, the company was in the fortunate position of being able to invest in internal research, and I led our sustainability pieces that are now carrying forward. So we do a lot of deep assignments. So we look in depth at the data surrounding our projects now. And some of you might recognize this as Leti, so a research group over here, are looking at how we rate buildings in terms of embodied carbon impact. So a lot of our projects, although they were completed by 2020, a lot of them were already meeting the best practice targets. And we're taking some of that knowledge and trying to share it across the industry. So the practice is supporting the UK Green Building Council's circular economy programme this year. And one of those pieces of work is looking at how we can reduce whole life carbon impact by incorporating circular economy. And I'm on the task group for that. So when the report comes out at the end of the year, I will share it. But the main piece of research I would like to share with you is about material passports. So last year we worked with one of our clients on a design project. So the client is the Grosvenor estate. So over here, the royal family hold a lot of estates, as do, some of the sort of historic lords, and Grosvenor estate is one of those. So they own huge swaths of city and the UK. Grosvenor have a huge portfolio. They basically own the majority of Mayfair in central London. And they're very unique clients to work for because they really believe in their custodians. So they need to take care of this property for future generations. And it's a really, really interesting mindset to be coming at this with. So when we were doing our design project, although they had a very robust sustainability framework in place, they were very keen to understand what more can we do. And this question led to a separate piece of research being set up for 5 months. And we looked at how we could accelerate material reuse. So our project was looking at 5 buildings in central London and what could we do better? And we thought we should be reusing materials. So this was one of 4 work streams, and I am going to go really quickly through this, but essentially, we believe that the circular economy is a necessity and not a choice. And what we were aiming to do with this work was increase material reuse within existing buildings. So we know that our current construction demolition practices aren't circular. They produce about 2/3 of the UK's waste, and the 2018 numbers have just been released, and it's about the same. So with our research, we're aiming to reduce the amount of waste being produced by construction in the first place by encouraging deconstruction and material reuse. And this concept begins with thinking of buildings as material banks. So it's seeing a building as a repository of valuable, high quality materials that can easily be taken apart and recovered. So if I'm really breaking it down, it's like building with Lego. So on the left-hand side, we have an existing building. And then the idea is you may not be able to reuse the existing building in its current format. So when this scenario arises, we should be dismantling our buildings, deconstructing them, cataloging the contents, and then the design team will hopefully be able to sort through and select which materials they can reuse in situ and which materials they may not have any appropriate use for, and they may send for onward reuse. You'll probably need to source some additional materials, and then it all gets assembled together in your completed building. So sounds like a great idea. Why are we not doing it yet? Well, the first thing is the cost of it. So it's typically cheaper to demolish and buy new rather than deconstruct and refurbish. We've also, for the past probably 50 years, we've been favouring chemical fixing over mechanical fixing. So when we're putting materials into buildings, we're gluing them together. So it makes them very time consuming to remove the materials, but also it damages them in the process, so they're not reusable. And then the last and probably the biggest barrier is risk. So there's a lack of knowledge about the material that's already in the existing building, and therefore we have a lack of confidence in it. So how can we trust that the material is going to perform as we need it to? This is where material passports come in. So the idea of waste being a material without an identity is really, really important to grasp for the purpose of material passports. So the aim of the passport is it gives the material an identity, and then that knowledge about the material can give us confidence in it and enable the successful reuse. So like my passport contains key information about me and where I've been, so does a material passport, largely around the condition and the original specification of the material. So this is our vision. So if you have a concrete block, you might have some key info. So the first one is having a unique identifier. So you're able to find it again. And then you're trying to capture some information that you may know from the original manufacturer, or you might be able to take a guess at. And we looked at ways of doing this. There was research in place for new buildings. There was research in place that relied on manufacturers to produce the data, therefore, again, aiming at new materials. But what we were trying to do was deal with existing buildings and unlock existing materials. So what we've done is build a materials database for a project. And the idea is that you take your existing building to be redeveloped, you view it as a materials bank today, you have to go through a material identification process. So these could be surveys. So at each stage of the deconstruction process, you might be surveying materials, you might take some away for testing, and you're capturing all of that data in the materials database. And over time, this will grow and grow. And the actual the user interface is the material passport, and I'll show you what I mean by that in a bit. So I have a couple of references into other research pieces that have been carried out that are really good. And this page is just explaining how, at the start you might not know a whole lot, but if you can link it into your design process, into your 3D models, which we use all the time, then maybe over time the material database can grow as this project evolves. And we have provided some ways of people to implement this. So this was meant to be an open source piece. It was meant to help the industry. So we tried to keep it as flexible and accessible as possible to all teams of all scales and sizes. And we have produced a number of tools to help people get started. So project teams contact me and I come in and give a presentation to them and help them get this started. And the idea is that as an industry, we can develop this thinking a little bit more, because as a practice, we don't have all the skill sets we would need. So what does it look like during the design process? Well, we work in Revit, which is a 3D modeling tool. And we know that we can't overload our models with information, because if we do that, they become really slow and difficult to use. So by keeping the majority of the information in a cloud-based database, we can then actually just use the technology to import any info we might need into our models. Or what I've been doing is having a second screen and just having my database open on the right and my model open on the left. And how I use it during the design process is, if I'm putting in a door, for example, I'm putting in my approximate opening size, and I'm looking to my database to see if I would have any doors that would suit that. And if I do, I can tag it, and then the information gets transferred across to that door. So that's the thinking behind it. And then when the building is built, you will be able to access that information again. So if you went up to a door, you went up to a block, you could scan something using a phone, a QR code on your phone, and it will display the information about contained within the material. And we've also identified loads of problems and loads of future opportunities that we're presenting out and saying, look, we'd love, if anyone has any experience in this, we'd love to take a look at this. And it sort of plays on some of the challenges around the softwares that we use. So I hope maybe in the years to come, you might come across this work again and hopefully be able to develop it in some way. And if you scan the QR code there now on your phone, Android users will need to open a separate app, but you'll be able to view our vision for material database and, material passport. And what you're seeing is all of the information that we could possibly capture about a material. And that this explains why we need the passport, because not everybody needs to know everything. So it's a filtered view and it's looking at the database behind. I'm going to stop there. And hand over to Aisling, I think.
I'll jump back in.
Okay, perfect.
Yeah, Rachel, that was great. That was
Thank you.
15 minutes, bang on. Well,
On the button.
well drilled. Oh, yeah, round of applause from Gary. Thanks, Gary. Yeah, so Rachel, there's a lot there, and like I certainly have questions. I'm sure other people will as well. But it's really, really interesting, and we will be able through the recording or through a link just to access the content that you were talking about. So you might drop that into the chat when you have a chance. In the meantime, we'll go to Aisling. And Aisling, if you're ready to share your screen.
Yeah, I'll do that now. So
I think it links pretty well to the work.
Yeah, actually, so a lot of the stuff that I can't go full screen. It's not going to work, but I'm sure this will be enough. But so I suppose just before I start going through this, so I graduated in 2020, so last year, and straight after I graduated, I started working with UCD on Belfield 50, which was the project commemorating the move of the campus to the suburbs in Belfield and UCD, and I was there for 6 months. And now I am working for Grafton Architects. So that is what I've been doing since I graduated. So for my thesis, I started kind of looking, or I was very interested in the idea of net zero construction and the kind of idea that at the moment, if we're deeming a building to be net zero, we're only taking into account its operational energy and how it deals with sustainability from the handover until the end of its useful life. And this doesn't take into account the materials that have gone into that building's construction. So none of its embodied energy is taken into account. So that was kind of what I was thinking of, kind of like the discrepancies between having like a very carbon heavy concrete building and that being deemed as net zero, as opposed to having a building that is low in embodied energy and being maybe fully net zero. So I started looking at different ways of building in a sustainable manner. So using very low embodied energy materials or materials which have negative embodied carbon associated with their manufacture and use. So I had a whole like remit of different materials. And I started looking at how they compare with kind of conventional methods of construction. So concrete block, concrete, prefabricated concrete, all of those sorts of methodologies. So these are just two kind of examples of different ends of the scale. So one thing that was kind of being talked quite a bit about at the time was mycelium, which is a substrate of the mushroom plant, and how that can be used to bind other substrates together, so woody substrates, to create different methods of construction. So that was just kind of one out there idea. And then also Dow laminated timber, which kind of became a key starting point to my ideas of sustainable design. So Dow laminated timber essentially takes the idea of mass timber construction further. So it uses that idea that Rachel was talking about, where you're not using adhesives or glues to bind the timber together. So usually if you're using cross-lam, these are glued together, the different elements of timber. But in Dow laminated timber, you use hardwood dowels inside softwood, and they react together, and they basically are friction fit together, and they work really well. So I would kind of wanted to think of an idea whereby you could like this could start with the architect, and the architect could bring these ideas of using low embodied energy materials throughout their design process to create a building that could be thought of net zero from the ground up. So this was this idea, thinking of, there's this idea in Japanese culture of golden repair. So we have all of these elements in our cities. So these building elements that are like buildings as material banks, essentially, like you were saying before. And if we decide to demolish these buildings, we're getting rid of all of these resources, whereas we could just supplement them with something new and those resources could be used again. So I started thinking of how you could like bring this into a cyclical design process, starting with the architect. So this kind of came into the idea that if you have all of these elements, so say you have a building that's going to be demolished, this building would be demolished hopefully in a manner where the elements are harvested, and those elements then would be added into a local or regional inventory of materials. And this would be the starting point for architects to go to in their design process. So you would go to this inventory of materials. So if you're Dublin based, it could be a Leinster inventory of materials, something that would be regional enough that transportation wouldn't contribute too much to the associated carbon. And you would go to this inventory and you would choose the elements that you could use within your design. And then those elements could be then supplemented with low embodied energy materials. So for the structure, harping back to Dow laminated timber or mass timber. And then hopefully you would design for disassembly, you would design for adaptability and flexibility to hopefully make sure that the life of the building was as long as possible. But then at the end of that building's useful life, it could be disassembled in an easy fashion so that the process could start again. And those materials would be reintroduced into the inventory and architects could go on from there. So I started kind of looking at Dublin and earmarking different areas where there's lots of vacancy and dereliction, and just thinking about how much potential there is there in those structures that are possibly being earmarked for demolition and those elements won't be reused, but that these are kind of, they could be very useful to us and what is going to waste essentially. So I wanted to kind of start creating an example of what this inventory of materials would be like. I wanted to start creating an example of the inventory of materials. So I kind of zoned in on a specific area of Dublin. So this is around Tara Street, and this is where the new Metro North, one of the main Metro North stations, is going to be developed. And at the time, there was quite a lot of in the press and documentation about these buildings and ideas of like how much demolition there's going to occur in this specific area and what we're going to lose. So I started thinking like it was quite a good variety of different types of construction and different buildings from different eras. So I started to think of what is available to us in those different buildings that we could reuse if they were to be demolished in a certain fashion. So I started breaking down the buildings by their facade elements and then calculating the associated embodied energy with each of those elements to see what we would lose. And that was then broken down and kind of categorized. So I ended up with this inventory of materials, which would be, so I had one of these elements for each building, and it's kind of just like a visual representation of what we're going to lose if these buildings are demolished in the usual fashion. And it's kind of like shocking to see everything that will go to waste, even down to doors and timber elements and windows, things that could easily be reused, and in some of the cases were very new to begin with. So I started kind of questioning how we're dealing with those things at the moment and how the council kind of is thinking about demolition. And at the time in the development plan, one of the main things that was being talked about was this thing that buildings over a certain size had to have a material resource and management plan. But I kind of noticed a discrepancy between like this being the hopes for what could happen and actually the implementation of that in the city. So I wanted to then continue on from like the creation of this methodology to the creation of a sample inventory of materials, to then seeing how this could be implemented in design. So I wanted to design a building in as circular a way as possible using those elements. So I kind of broke down what I've been doing thus far into a manifesto of what I wanted to continue with. So this came down to the reuse of materials and their supplementation with low embodied energy elements, and then designing for disassembly, so the use of structure, like the layering of structural elements, which I'll get into a bit later on, and then designing for adaptability, flexibility, and using demountable elements and stuff like that. So one of the main kind of concepts that I came across in lots of research that I was doing at the time was the idea of systematic layering in construction. So this is the idea that the more independent each of the layers in your structure are, the easier it will be to extricate those from that end building at the end of its life. So if your structural elements are separate from your services and from your finishes on the interior, these can be easily changed out, and they can be easily changed as the use of the building continues. So this kind of moved into the idea of dormant capacity as well. So I essentially designed this building that it was, at the time, we were coming into lockdown for the start of the pandemic, and the idea of live work spaces was very prominent at the time. So it was this idea that you could create a modular building that could be multiplied across a site as need progressed. So this building was to start out as a live work space, but that could then change as the needs of the city progressed into only office space, commercial space, or stuff like that. So the primary structure of the building was to be prefabricated dowel laminated units, and these would then be encased inside a glue laminated external self-supporting facade. And this self-supporting facade was completely independent of the internal primary structure, and it meant that it could hold demountable cladding panels and hold glazing elements of its own accord. And these could then be easily interdependent from the internal primary structure. And it meant then that anytime you were adding in elements from the inventory, so if you're thinking about reusing glazing elements or reusing cladding panels, these elements might not have the same material properties as something that's new. So you might not be able to achieve the same U value in the internal space as you would be if you were using newly fabricated materials. So this idea of doubling up the facade means that you can double up on elements such as glazing, and you can make this void different depths to deal with different internal circumstances. And then using the external glue laminated framework meant that in certain places it could take on the load of the structure, and it would mean that it would expand the use of the building, where it would take, so where dowel laminated timber can't take very tall structures, that this could come into force and take the loads of the building, and it could create the concept that this building has a lot of dormant capacity. So if in times to come you need a structure which is 10 stories tall rather than 8, you have the capacity to add those in as time progressed. So internally, the structure began to develop in a way that so you end up with this this duplicated external fabric, and the build-up changes depending on the orientation of that facade, so that it can deal with different levels of privacy, different levels of light and stuff like that. But it also means that all of the structure is pushed to the external perimeters of the layout, which means that internally the layout is very flexible. So just for example, these structures kind of started out as duplex units. So if we were just to take this corner here, this would be the ground floor of a 2-bed duplex. And internally, all of the partitions are non-structural. So these can be moved around as the inhabitants see fit. But the main kind of idea of adaptability in this was that each unit was designed as per the kind of residential guidelines of the time, but also that each unit was given additional unprogrammed space, which could be used by the residents in as kind of a working office, like home office environment, but could also be changed to be used in whatever way they see fit. So it could be a granny flat, or it could be extra living space, an extra bedroom. It could be partitioned off from the main living area and sublet as well. So that was the idea of kind of flexibility in the short term. And then moving on, as you were saying about designing for disassembly and using non-chemical fixings. So I was thinking about how you would be able to design in a manner that mass timber elements could be fitted together in a way that meant that they could be easily reversible, and all of those elements could be taken down when the time came for the building to be demolished. So this was an idea of how that glulam structure might work, and how with the idea of trying to remove as much concrete out of the construction as possible. So this was an idea of using stone footings for all of these mass timber elements rather than using concrete, and that these were then kind of as a visual representation of what was going on in the building, that these were connected by gabions, which were then filled with demolition waste as kind of a visual nod to the public of how the building might be constructed. So kind of one of the main elements then that needed to be rectified was this idea of how do you incorporate reused elements into a structure whose fabric is newly manufactured. So how do you bring in glazing elements and attach those in a demountable way to a new structure? So these are ideas of reusing brick panels that were cut from those other structures from the inventory of materials. So they, instead of trying to take out the bricks themselves and reuse those, that the brick facade would be cut into meter by meter panels, and it would then be fixed to this kind of timber cassette framework and then dowelled back to the external facade. And the same would kind of occur when glazing needed to be incorporated. So between the structure, this would be broken down depending on the specific dimensions of the glazing elements that were being used, and they could be fixed in then as construction continued. So this is just this idea of inhabiting that void then between the primary structure and the self-supporting facade, and how this could kind of add to the space and deal with things in different ways. So in the normal construction, this fabric here would be as close to the external facade as possible, but in places this pulls back and creates a winter garden, and this kind of changes depending on the orientation. So to the south you might have a Juliet balcony or a window seat, and stuff like that. To the east, this becomes narrower because you want the morning light into your bedrooms and into your workspaces. And this is a more more private kind of thoroughfare. So the horizontal elements create kind of a visual barrier then as well, and then creating a winter garden. So just kind of to finish up, I kind of wanted to look at one of the main things, I think, in the public realm anyway, is what would this kind of idea of reuse look like? And like, would it be terrible, basically? So I was kind of like thinking of how you kind of end up with this patchwork of materials and how it might actually look nice. So those were a few things. But then the main kind of element was the idea of cost. And I did a lot of research into that and how maybe at the beginning of this process, the costs might be slightly higher. But if you think about the maintenance of a building whose elements are very intertwined and difficult to take apart from each other, those costs cumulatively over the life of the building become very high. And this is kind of rectified by dealing with this at the start. So you end up with much lower costs. And then just the last thing, I kind of, the building that I designed, I went through and did like a whole carbon analysis of how much embodied energy would be associated with it, and then at the same time did a concrete equivalent. So if I was to design that building in a normal manner, how we usually build at the moment, what that would be like in terms of its embodied energy and just the different elements and how they relate to each other. So it kind of was like the end point to the thesis to say that maybe it would work. So yeah, and that was that.
Thank you, Aisling. Thanks,
Thank
Aisling. Great to see that project again, and all its detail and resolution. I think one of the well, I suppose there's a lot certainly of a common ground, I think, between the two presentations and your approaches, and maybe a lot of questions that might come out of that. If people have questions or comments, you can either just pipe up or put something into the chat, and I can come to you, or I can just read it out from the chat, whatever way people want to go. Aisling, I might just ask as an opening question whether you now you're working in practice and have been working in practice with Grafton's for the last while. Do you find that the thinking that you developed in that thesis, which covered many aspects actually, like demountable assembly, reuse, thinking about materials, to a certain extent the material passport idea, do you find that coming into, that you're able to translate that into practice, let's say?
Oh, 100%. Like one of the projects that I'm working on at the moment is actually it's a adaptation of an existing building. So I think at the moment, I think it's one of the main elements of lots of projects at the moment, and it's very much being talked about. Definitely anything that I've come across, existing buildings, that's the way people want to go now, is to be like adaptive reuse and reusing what we have. And the idea of kind of the carbon life cycle of materials is really coming to the fore at the moment as well, and using less concrete and that sort of thing. So definitely, yeah.
And again, I might go to Rachel and then come back. But so Rachel, I was struck actually in both cases that, Aisling, you were referring to Dublin City Council in a way as a sort of, you might say, custodian of the material in their in their jurisdiction, right? And then Rachel, in your case, you were talking about the Grosvenor estate as, you know, the opportunity of the Grosvenor estate, because they basically own all of it, and so that gives you a sort of capacity maybe to start to change policies or change approaches, you know, when you've got that. Was that an important element for you, that, you know, you know, because I suppose one of the things that occurs is that how do you get this to operate at scale? Like, is it a case of it just happening as a once off in every instance, or what scale does it operate best at, might be another way of putting it.
Well, ultimately, it needs to operate at city scales. And like what Aisling was saying, that projects are pooling their resources. So at the moment, we're still very much in the demonstrator scale. So getting the likes of these custodian clients, the ones who can afford to invest in this research and who believe that their role is bigger than just being a developer and making loads of money. It's really helpful to get the weight of that kind of client behind it. And through the UK Green Building Council, they have met other clients. So at the moment, the Crown Estate, which is, I think, Her Majesty's private estate, is working with the Grosvenor Estate to try and do material sharing as a demonstration between the two. There's a lot of problems in getting the research thinking into practice, particularly around contracts and procurement, and it essentially flips things on its head. So does the client have to buy all these materials up front and then transfer them to the contractor down the line? How do you integrate that into your specifications? So I'm involved in lots of research groups that are trying to unpick all of those individual problems, and the likes of the Crown Estate and Grosvenor Estate are supporting that work initially. And the main thinking is, if we can kickstart it within these levels of big clients with numerous large developments going on, set the work in place, and then hopefully people will be able to just jump in without having to fund a lot of that thinking themselves. So the ultimate goal, London is one of the cities there's a current EU funded piece called Circuit, which is looking at circularity across 4 European cities. And this particular project was a demonstrator for one of them. Now, unfortunately, the project has gone on hold, but we're looking to finish out that piece of work with Circuit. And what it's looking to do is to develop the business as usual from a carbon and a cost perspective, and then to look at these reuse at a bigger scale. So taking material out of a building and putting it back in, and to build that business and carbon case around it, so that we have the data to then bring it to clients. And if we can start the secondhand materials marketplace and speak with suppliers, so I speak with all of our suppliers about this, and they're willing to take this piece of material, refurbish it and sell it back to me as secondhand, by tackling it all individually, hopefully it'll come together.
But then, because I suppose I was thinking about precisely what you were touching on there, the question of how that can work within a contract or within a tender even. I mean, and then how it works on a site. Like, is it the idea that the contractor takes ownership of all the material, one version, and then they have a problem, or they have a challenge in terms of how do you manage that material on a site?
Well, so our vision would be that by the time the contractor comes on site, we have identified the materials we'd be looking to retain. We will have worked with a demolition engineer on the design team side to correctly identify that these materials can be extracted, and we'll have developed the specification so that there is testing procedures in place. There's 2 examples that I can give you of what we've been doing right now in our own practice. So the first is one of the manufacturers for raised access floors. So we use OneClick in-house, which is software that Aisling was mentioning, and actually all of our architects are trained to use it. It's a bit unusual. Usually it's an external consultant, but it works really well for us because it means we can make really informed design choices, and we can help our clients to make informed design choices. So we present a design option, and they have the carbon numbers and the financial numbers, and then they can select where they want to invest. Raised access floors in offices, which are essentially a floating floor, and you leave a void underneath them to run services and things like that. It's really, really common in commercial architecture, and is one of the highest carbon numbers when you look at the architectural elements, so exclude the services and the structure. So a manufacturer has gone and researched and has figured out a way to take back raised access floors. So they often get lifted when a tenant leaves. because you need to clear out the things in the floor underneath. So when they get lifted and get ready to be thrown out, they take them back as free feedstock into their reuse marketplace. They test the panels, they have a way of testing them and recertifying them, and then you can specify a refurbished raised access floor tile. So that already brings down the carbon numbers, but the manufacturer has taken on that responsibility. So from our perspective, it's very easy. I just put that product into my specification as usual. Taking that thinking to something that doesn't exist yet, we try to put reused sinks into a project for the Crown Estate. And we fell down when we went out to tender because we couldn't secure 56 sinks that we needed. So what we've done is we have written our specifications as new, and then put in a supplementary piece to the contractor, and we've invited them back as tender options. So the contractors will hopefully be bringing these to us. And I've been working with NBS, so the specification software over in the UK, and with suppliers to try and find a way that we can even do partial replacement. So contractually, if they can only find 25 sinks that would meet our criteria, that we can accept that plus 25 new equivalents. And then also looking at how we specify for it. So we slightly oversized our bathrooms so we could accommodate sinks between 450 and 350 mil width. And we were developing through the remainder of the Grosvenor piece of research, how do we grade and quantify, damage that has been done to a secondhand piece. So you might say, I need a grade 1 aesthetic, or clients fine with a few chip sinks in the cleaner's bathroom, so they'll take a grade 4. So how do we have these grading systems? So this is all going on in research groups and being trialed on our projects and other people's projects to try and hammer out the main issues.
The demonstrator projects are key because they just show. I mean, in a way, Aisling's is like a quasi demonstrator project.
Yeah, absolutely. It's great. It's great research thinking, and that's exactly what I'm trying to do. So being a few years down the line in my practice, I'm able to say, okay, this is all brilliant thinking. This is how we might be able to do it. And as an architect coming in with that creative mindset, I'm able to look at the opportunities, identify the tools that we are missing as a practice, and then my work is looking at developing them up in a really efficient way, so we're not adding to our workload, but able to make meaningful decisions when we're in practice.
Just a follow-up, I have a follow-up question on that as well to both of you, but just Gary has something along the same lines. Gary Miley is asking whether, it's just in the chat there, how would we track and trace individual elements like windows and doors? Could we chip or barcode them? And does this extend to materials like individual bricks, slates, etc.? What's the...
Yes and no. So there are two methods of tagging once you get into the world of BIM. So designing in 3D models, but then embedding loads of data within the model for the client to then use in the future. That's BIM. So BIM has two ways of classifying systems and components. So a component is a finished thing. A door is a component, for example. So it has other components attached to it, whereas something like a ventilation system is a linear duct, and you could even say that a wall is a system because there's a large quantity of it, and within it there might be individual components. So we're looking at utilizing the two different classifications. So would I tag every single brick? Probably not when it's going into the building, because I don't need to. And at the moment we're using QR codes. So one of our clients has now specified that when the building is being built, there is to be a metal QR code tag fixed to every component, every window, every door, that sort of thing. And then we're going to sporadically place them along a system, and that leads you back to system. Arguably in the future, if you're going to break apart those bricks individually, you may then want to get to the point of tagging them individually, and maybe then you would look at chipping them. So RFID tags are a more intelligent tagging method, and we do use them already on active equipment, so like cooling, aircon systems, things like that, so that the unit can speak to the building management system and transfer data to it. So if there's already going to be an RFID tag applied to something, then we should utilize that. If it's a static element like a door, you can just use a QR. And then apparently the oil and gas industry have figured out ways of chipping fluids, which is a really interesting way of then thinking about it. So I need to scratch my head and figure out who I can ask those questions to, because imagine if we could get them dropped into bricks during the process. That'd be really interesting.
I mean, it strikes me as I mean, in a sort of analogous way, it's like considering it reminds me of tagging birds, flocks of
Hmm.
birds and so on.
Yeah.
Like, so that you're in this world, there's an ecology of existing materials, effectively, that they're all in the world already, but
Hmm.
they might migrate into new territories, new places
Yeah.
over a lifetime that could extend. Well, because effectively they're inorganic. Well, they're organic, but they're inorganic, so they're stable to a certain extent. So they might continue
Yeah.
in life through several iterations. A sink might land in. Well, I mean, it's interesting to think about that. What I find interesting about you both is actually the way you talk so passionately about elements and components, bricks, um, like the new Louis cans, ask a brick what it wants to be, where it wants to
Yeah.
be in the future or something like that. But there's something interesting, isn't there, about the way the relationship it establishes between you and materials and elements. Would you
And
say?
going back to Aisling's thinking, it's going to encourage us to invest in better materials. So at the moment, a client doesn't really have a reason to buy the more expensive material because it's a whole thing. So that idea of, using the stone in the ground, because then it could be reused or could be swapped out or something like that. That's exactly what we're trying to do. So trying to encourage our clients to use less material and to use better. So if you're going to do marble finish, could you do it on a slab that we can mechanically fix? Because I know it's a front of house element and you're going to want to change it in 5 years' time, but I'm going to be able to sell that marble slab for you and recoup that money back for you. So something I haven't really touched on is there is a platform called Medaster, and you load your BIM model up, and in theory it reads it all. It's not quite there yet, but we've been doing case study with them to see how we can interface the thinking. So our thinking is up to design stage and construction and putting things in place, and then at the point where the design team walks away, what's the next, where's the handover, where does that data and information go, and how does it get secured that it's not going to become redundant because someone's forgotten about it. So what Medaster have been doing is collating models or IFSC files exported from models, and the data embedded within them and the materials embedded within them. And their vision is that you could look at a city scale, for example, and see, like what Aisling was doing, her work, looking at that city and saying, where are these pockets of materials? And can we predict that material release? I think that's a really important thing. And then being able to explain to the client that steel beam can hold value. So it's worthwhile investing in it being able to be dismantled and reused elsewhere. There's a huge piece behind it because at the end of the day, they need to make money. But equally managing, I think a lot of what I'm trying to do is make it less overwhelming. For a lot of people, sustainability and this thinking is overwhelming. And if you overthink it, you get so overwhelmed, you'll never do anything. So with all of our projects are now going to have a little materials database. It might just be the doors. It may just be the windows. It may just be one floor, but I'm trying to encourage each client to just do a little bit now. And then once they get comfortable with it, maybe on their next project, they could be slightly more ambitious. And that's how we scale it up.
Yeah. So, but it's funny because, well, again, I'm just wondering about the state. You talk a lot about pieces of research, like obviously research going on in your practice and sharing through the various things like Circuit that you mentioned, the EU project, and so on. Is there a spirit of, let's say, open access sharing, or is there an amount of proprietary commercial, like that interest in saying, well, look, we know how to do this, but there's a sort of commercial value to knowing how to do this, so we need to protect that. In terms of, like, I'm thinking about software, say, or
Mhm.
applications or whatever.
Yes and no. So some people who have invested a huge amount of money into building a piece of software like Medaster, they're very closed about it because it's their business. As an architectural practice, this isn't our primary business. And what I've produced is actually a methodology. I'm building on existing softwares because I'm not a software developer myself. I think generally in the world of sustainability, people are a little bit more reluctant to make everything a business model. We believe in this for the right reasons, and it's a bit more altruistic, I suppose. So when this work came about and we were developing this thinking, we did have to sit down as a practice and say, well, what is the right thing for us to do? And we spoke with the client about what is the right thing for us to do. And we felt that we would have much more impact if we could share it and make it open source, which is why we do. At the end of the day, we still get credit a lot of the time because people are using our thinking and they'll mention us. And to be honest, to a certain extent, we're already thinking about the next thing as well. So we're constantly evolving ourselves. So for us, it wasn't so important that we monetize it. And a lot of architectural practices, I say a lot, 2 architectural practices have developed ways or softwares or add-ins to calculate embodied carbon in their projects as they design.
Yeah.
It was really, really relevant at the start of this sort of conversation 4 or 5 years ago, where maybe those extra licenses might be a bit inaccessible. So one-click license, a floating license for a practice like ours is about £3,500. So for some practices, it's going to be prohibitively expensive. And then that's great where other architectural practices have come in and said, okay, we've got a rough and ready tool. But unfortunately, within London, there is a drive for regulating embodied carbon, and at a minimum at the moment, any schemes of a referable scale, so schemes of a certain size, quite large ones, need to, by the GLA, so the Greater London Authority, all planning applications being submitted within the GLA scope must come with a whole life carbon assessment attached to them. So if you want to have that assessment for submission, it needs to come out of a software like OneClick, which unfortunately you've got to pay for.
Okay.
But it's a mix.
Aisling, I'm just thinking about the future, just sort of how you feel things are going to. I mean, we're now facing, well, in Ireland, we're facing into a 10-year, well, a 5-year, 2 5-year horizons, let's say, in terms of reduction of carbon emissions. You talked about relatively little, I must say, since announcements last week compared to other sectors, but just still major challenge, I would have thought.
Yeah.
Do, do you, what's my question? Do you think it is going to redirect your energies as an architect, or do you think it actually it precisely draws upon your capacities as an architect to be able to think about this? Do you know what I mean? Does it actually ask you to do new things, or does it let you use your, the skills that you've already developed, more fully, let's say?
Yeah, well, I mean, firstly, I think like when I was researching, this was only like a year and a half ago, there was not, I suppose, there wasn't that much available to me to work off of. And hearing you talk about it, Rachel, there's so much going on that I wasn't aware of or that has happened since then, which is very exciting. Like things that I thought that would take like 10 or 15 years to kind of come to fruition and to start happening in practice. And to hear that they're actually happening is incredible. So it kind of goes to show how fast things can progress when people want it to happen and when the legislation is there for it to happen. So I think definitely that things are changing in government at the moment is a big thing. And I do think that definitely like the discourse in architectural practice at the moment and other people in that I know who have just started out in practice, it's definitely one of the most common kind of topics that people are working on at the moment. And most projects that are happening do have an element of this idea of circularity. And there's lots of workshops and kind of, it's probably one of the most talked about things currently, I would say. And yeah, it's just great to see that it's actually occurring. And it would be great if it was that like, not just practice it like certain practices where you're doing things, but that it was like a local or council related thing, and that it was kind of more of a like there was more regulation around it, and it was something that actually has to happen. That some percentage of every building from like 2022 on has to be taken from a certain, or has to have a material passport associated to it, or has to be taken from an inventory of materials. But yeah, definitely, I think for the future, like things are definitely ramping up, and over the next few years, hopefully, things will change.
Well, it does feel like that. I mean, even I know. Well, there you are, right. I mean, making connection there to St. John while she was asking. If I mean, I know St. John is developing a draft tool to help designers integrate design for disassembly and reuse in day-to-day process, and drop St. John an email about that if you're interested.
Yeah, absolutely. I'm also doing one, so let's swap tools and see if we can amalgamate the thinking.
This is it. I mean, I think this is it is probably one of those, there's that famous diagram, I think, in physics of like there's a certain point. I can't remember. I think it's a state change of state or something like that. There's a point at which enough connections are made between isolated elements that suddenly you get this kind of amazing burst of energy into a system, because people like, so maybe it's even happening here today, but you know what I mean, the more of those connections are made and the more people start to share practices and so on, it does strike me that it becomes, to borrow the phrase, the new normal or something like that. And it's also interesting that the expectations of possibly all actors now within the system, as in clients for sure, contractors, probably project managers, maybe. I mean that, we didn't really talk about risk and insurance, but I imagine that's a big part of it as well. People who manage risk.
Yeah, that's been being addressed within the UK GBC group, and it's being led by Grosvenor, because there is this perceived risk. If you want to check out the UK Green Building Council website, is a great resource. Letty is another great resource. It is UK based, but I think there will be a lot of transfer of thinking.
Right, thank you, Rachel. I'm going to ask you if you could put those last two references into the chat, and then we'll have basically sucked every single bit that we can get from you in this hour for both of you, which is great. Look, I think that's really been fascinating, I have to say. I think a lot of people will benefit from this, people on the call here now, but also people who will tune in later on and pick it up when we put it on YouTube. It's a whole, there's lots in this area, and I think it's something we'd like to return to. And I'm sure there'll be follow-up questions. But for now, I would just like to thank Aisling and Rachel for giving up their lunch times. It's a working day for both of them, so very appreciative of that. It's great to see graduates from here going on and bringing, well, the work that they produce here, but also bringing it into practice. I think particularly, I think that's great to see, and great to see the work that you're both doing. So thank you very much. Just to mention, in terms of current, we have this series called Actors at the Margins that we're hosting here on Current. So the next one of those is on this Wednesday at, I think it's at 4 o'clock. So there'll be details of that going up online as well, and then more next week. So thank you both very much, and thanks to everybody for your questions and comments and for tuning in. Oliver St. John, by the way, Gary Miley says thank you for the presentations. Oliver, not Oliver St. John, Oliver Canan says super project, Aisling, great to see this kind of research being applied in practice. Rachel, thanks both for fascinating presentations. So a lot of, I think, appreciation for your contributions today. Thank you both.
Thanks so much.
Thank you. Love speaking with you. Bye.
Yeah. Thank you.
Thanks. That was fantastic. Great to hear. Okay. So, Olivia, that'll come to me as a recording, I guess.
Yes. I'll stop recording now.
Great. That was very good, I thought.